problem-solving skills to solve this heuristics problem from Primary Mathematics 2022, Book 2A, page 165. Now, the strategy we're learning today is to work backwards. Sometimes when you're working problems, it makes sense to think about the end and work your way back to the beginning, and this is one of those problems. So let's read it and see if we can understand what's happening. I think of a number. Okay, that could be anything. I'm thinking of a number. I add 7 to the number. Okay, I've got my number. I'm going to add 7 to it. Then I subtract 11 from the result. The answer is 24. What's the number? So again, I like to visualize what's happening. So I'm actually going to think this through because the first step of the problem solving method is to understand. So let's understand what's happening. We have a number. What happens to that number? We add something to it. What do we add? We add 7. And then we have a new number, right? So that's that new number. Then what's going to happen to that new number? We're going to subtract 11. And then when we do, we end up with a new number, which is 24. Okay, so the question is, what's the number? Now we're going to make a plan. Our plan, which we already helped you to come up with your strategy, is to work backwards. You know where you end up. You know you end up at 24. And you know that there were steps that helped you to get to 24. So can you work the opposite way to see if you can get back to the beginning? You definitely can. This is the part of the video where I want you to pause and go do the problem or solve it. I want you to see if you can use the information here to work backwards to find the number we started in the beginning. Then I want you to come back so that we can compare notes. Let's think through this problem by drawing a model to help us make sense of what's happening. Okay, I'm going to use 2 different colors here. So I had a number, switch that one. I had a number. This is what I was thinking about at first. We had a number. What happened to that number? We ended up adding 7 to it, and we got a new number when we did that because it changed because we added some more to it. So we had a new number. Then what did we do? Then we subtracted 11 to that, and we had a number, but we know what this number is. This number was 24. So can we think about working backwards to get to this part here? Sure. Let's use what we know about part-whole relationships to figure this out. I'm going to have all my colors around here. Okay. So again, I'm thinking of a number here. And I know, so I'm actually going to draw that here. Let's think about this number here. And I know that I subtracted 11. I took 11 away. And when I did, what did I end up with? 24. Right? Because we took away a part. So we had a whole and we took away a part and we ended up with another part. How could I use these 2 numbers here to figure out what this number is? What could you do? Well, I see 2 parts and they make a whole. So if I were to add these up together, what would we get? You could add your ones up. I see I have 4 ones and 1 1. That's 5 ones. I'm going to add my tens, 2 10s and 1 10s. That's 3 10s. So I end up with 35 here. Okay, let's think about this. So let's see if it makes sense. So we're saying that 35, and I'm going to subtract 11, would give me 24. We could check that and make sure it gives us the right answer. It does. So I know that this makes sense. Is that my original number? No, these are still one more thing. So I had my original number. I added 7 to it, and I had 35. Let's think about that part-whole relationship again. So I had a number, and I added 7 to it. What would that mean in the part-whole? That would mean that this was a part, the other part was 7, and when I did that, I ended up with the whole of 35. So if I'm thinking about this, so something plus 7 gives me 35. How am I going to find what this is? What operation could we do? We could subtract. We could say, well, 35, and if I take away 7, I'm going to have to do some renaming here. I could rename a 10 for 10 ones and add that to the 5 ones that I already have there, and I end up with 15 ones. I know 15 take away 7 is 8, and I have 2 10s, so now I have 28. It's 28 and 7 more, 35? Yep, so that checks. Interesting. Here's what's interesting that I'm noticing. I'm curious if you notice it too. We subtracted 11, but in order to find it, we added. And here we added 7, but in order to find this number working backwards, we subtracted. So in working backwards, we actually did the opposite operation, which is really cool. Now, how would we check to make sure this makes sense? Let's work through it and make sure these components check out. 28 and 7 more is 35. 35 take away 11 is 24. That works, and it makes sense. You can also check it by trying another method. I'm curious what other method you might use. Maybe you want to grab some base 10 materials and check that out. You can do that as well. Working backwards is great, especially when you know the end result and you're trying to find where it started from. Go ahead and use this strategy to solve the next 2 problems in your student book and see how working backwards is just another great tool to help you solve a variety of problems.